Well, my project is basically about visualizing data gathered from Twitter to visualize using AlloTwit. So let's cut to chase and go to the demo time. Well, I'd like to call for a volunteer. So does anyone here using Twitter? Are there anyone who's using Twitter? And the more important thing is that ideally you have less than 100 people you're following.
I think I have 3.
Only 3? I think 3 is a limit. So is it okay if I use your storage? Okay, so I'll need your, just another thing. Are the people you're following like can be seen like under PG-13? Okay, that's fine. So can you give me your screen name, your username screen name? Give me a second.
I don't think pretentious is a good choice.
Come on. Unless something you ask.
So come again, screen name?
L British, L
R
L.
L.
No. It starts with L.
L.
And then R-I-T-E-S-H.
R-I-T-E-S-H.
Yeah. Sure.
So that's all?
Yeah. That's it.
Okay, cool. So I'll first get the data. Let's see.
So now you guys can follow me.
Oh, it's getting all the data, the person you're following, and just all the data I needed. And now it's getting all the images for the people you are following, the profile image, their profile image. Now I successfully get all the data. Let me show the result. Wait a second. Okay, so your screen name again is R-L-R-I-T-E-S-H, right?
Yeah, that's right.
I think there's a J, right?
No, that's right.
Okay. Yeah, that's basically the result. I think full screen is a little bit. Oh, anybody? Yeah, thank you for turning off the light. So that's basically the all. What I'm trying to do is that I get all the data of the people you are following, and I model the connection between them, as you can see here.
Is that Serene?
What?
Yeah. That's Serene over there.
Oh, okay.
Bird in her
So
head.
yeah, as you can see, there are all the people you're following.
Here's Casey.
Yeah, but the result may be a little bit chaotic if I turn over the camera. But there's an easy way to fix that. Now I just turned on the beer bowling. So you will just follow my camera no matter how I rotate it.
Smoothed billboard.
Yeah, exactly. That's how.
Yeah.
So
Because you're using Slurp.
Yeah, exactly.
Yeah.
So I guess that's a demo. Let's come back to my boring presentation. Can you maybe turn the light on, please? Okay, thank you. Okay, after the demo, I talked about how I design and implement my project. Well, my project is basically about data visualization. So there's both data acquisition part and also visualization part. For the data acquisition part, the first thing I have to do is to get data from Twitter. So how can I use it? I basically use a library called TweetCurl library, as you can see there. It will basically handle all the authentication, and it has some great wrapper for REST APIs for you to use. It's very convenient. But I've encountered an issue, maybe a problem created by Twitter's API. So here's the problem. Since I want to model the following relationship between say n people, and there should be order n squared times of comparison to check if whether two people are related. So the good thing is there's a Twitter API directly to check if there exists a following relationship between two people. But the bad thing is there's some limit to call the Twitter APIs. So for an authenticated user, you can only make 350 calls per hour. So under that circumstances, I can make I can only compare between no more than 18 people. So that's far less fun enough. To solve this issue, instead of calling the Twitter API to check directly the connection between two people, instead I call the Twitter API and to get the list of following IDs for each person, and I store them to a file, and I make a comparison based on the file. So by using this method, I reduce the time to Twitter API calls from order of n squared to order of n. So that's it. And on the second part, I have to parse this data I gather from Twitter and to use them. I have to parse them. So I use the tiny XML library called recommended, and so since all the XML files, they're basically tree data structure, I designed some recursive function calls to parse all these XML files. It's quite straightforward. And next part, I have to so getting the Twitter profile image is a little bit tricky. I mean, within the XML data I get from Twitter, I have all the URL for profile image, yet I cannot read them directly from URL. I have to, the thing I did is to use a library called curl.pp, also the library called recommended, to make HTTP request to get the images and to save them on to local files. So that's basically all the steps I took to do the data acquisition part. Now let's turn to data visualization part. Well, for data visualization, I first created two types of agents. One is called the vertex, and another is called the edges. Well, the vertex model a person by showing its profile images, and the edge will model a following relation between two persons. Well, as you can see in the demo, this one, the edges have different colors. So what do they mean? Well, the right side denotes that this person is being followed, and the green side denotes, as you can see here, the green side here denotes that this person is following other people. And as you can see here, there's some green spheres, right? So the green sphere will be generated if the profile image cannot be successfully loaded in AlloTwit. So I just use green sphere instead. Well, okay, let's go back. Well, for doing the layout, I use the false space algorithm, not different from Qian's solution. And thanks to Matt, Bazark, and Qian, I implement this algorithm, and I think it's perfect for next scenario. And okay, so next, also I can see in my demo, I also did beer building to optimize the display. Well, that's basically about the implementation of my project. I want to talk about the implication of my project. I mean, how do this visualization matters? What kind of hidden relationship do they show? Okay, I want to show some example here. This is the thank you for taking off the light. This is the